Good morning, everybody. My name is Keith Lacko. I am the Global Vice President of Marketing for Maxcess. And we're excited that you guys have been able to join our webinar today. This is the second webinar that we've done so far this year, and we're planning to do a lot more. We've had a really good outreach and attendance on these, and we try and keep them short with a lot of Q&A time with our subject matter experts. And today what we're going to talk about, we've seen a lot of this come up in the industry recently, is what we like to call tooling intention. And especially as materials have been changing and liners have been getting thinner, and we've seen a lot of variability in materials. It's had some impact on die cutting and as well as tension as we're going end to end on the printing press. With me today are subject matter experts who are much more experienced in these topics than I am. We have Greg Wells, who is our business development manager, and Daryl Whiteside, who is our director of business development. And they bring a wealth of knowledge and press side experience to help all of our customers run better, faster, and smarter. And we're going to focus on these two topics today. If you look at your screen, in the middle of the screen right next to the chat is the Q&A session. As we go through the various slides, if you have a question, please click on the Q&A, write your question in, and we will get to those as we get to the end of the presentation. But without further ado, let's go to the agenda. Eva, if you'll go to the next slide. So we're going to talk a little bit, Daryl's going to start off the presentation, talk about end-to-end and how that all impacts as we look at tag and label printing, as well as web converting. We've got customer liner challenges. We've got a rotary tooling overview. And then we really dive into tension impact on tooling and production. Greg and Daryl will leave you with a few tips and tricks at the end, and we'll get to the Q&A session. So without further ado, and again, thanks for all your participation today. We have over 100 people on the chat that'll be in and out. Really looking forward to sharing our insights and information with you. Daryl, I'm turning it over to you.
Thank you, Keith. Good morning, everybody. And again, I'd like to reiterate, we appreciate your time in joining us in this webinar, and hopefully it will be beneficial to you. Again, my name is Daryl Whiteside. Eva, can you go ahead to the next slide? This is going to be a technical presentation. That's the intent. So we're going to try to keep it non-commercial, but I think it's important to talk in the beginning to just lend a little bit of credibility to who we are and what we do. As far as Maxcess. Maxcess is an end-to-end solution provider for almost all of your web handling needs. Maxcess is a collection of very well-known established brands with our Fife guiding systems, our Component-X Valley Roller and WebEx specialty engineered rolls, Mag Power tension control, which we'll be talking about today, Rotometrics, rotary die cutting, as well as print cylinders. We do Maxcess vision systems, as well as slitting and winding systems from Tidland. So the important thing to know here, Maxcess is more than just a sum of the parts. All of these products, all of these brands, and all of these processes interact with each other in your web process, and they're all tied together by one common thing, the web that's being transferred through the machine. So when I say it's more than a sum of the parts, yes, it is a convenient thing to buy all of these products from one location, but even more so, it's the knowledge base that comes with understanding how each one of these things is affected by the other products in the web itself. So that's who we are, and that is who Maxcess is, your end-to-end solution provider. So we'll go to the next slide, please, Eva. So we also understand we've made and are continuing to invest in Industry 4.0 solutions. Well, what is Industry 4.0? Industry 4.0 is the Internet of Things, and it's having the ability to actually tie all of your different processes together and to collect data and to control those things centrally, since they are all tied together by the web. When I say web, I mean the actual web that you're running your process. But what this gives you is the ability to increase your productivity by being able to examine data from all of these different points and actually controlling them together. It also eliminates human error, and it increases the quality and speed of your changeovers, because as we all know, if the web isn't moving, if your machine's not running, you're not making money. So Maxcess is dedicated to investing in this and continuing to expand our offerings that allow you to tie all of these product lines together. So in the end, our goal at Maxcess is to help you run better, faster, and smarter. So with that, Eva, if you want to go to the next slide, I'm going to go ahead and turn this over to Greg Wells, and we're going to begin the presentation.
Thank you, Daryl. The customer liner challenges today. So as we all know, the liners are getting thinner, the face stocks are getting thinner. We've been seeing a lot of variations in liners, and being able to adapt to these changes is very important. We offer adjustable anvils so that you can now change your clearance as the liners are changing. And with these thinner liners and thinner face stocks, the adhesives are changing. They need to be more aggressive because there's a thinner coat weight on them, on the thinner faces. So because of that, they're more aggressive. And so you need to have a non-stick coating like our rotor repel on the blades so that you don't have this adhesive buildup. This adhesive buildup will give you downtime while you're cleaning it off, but with rotor repel, non-stick coatings on the die, it makes it easy if it even sticks to the die. And converting this product then and being flexible to have these different products that we offer to mitigate these issues is very important, especially as you start to run thinner liners, keeping the heat mitigation down as much as you can is very important. Next slide, please. So there's a lot of factors that affect die cutting. The web tension, how the images are laid out on the web, the stripping roll that you're stripping the matrix away from the liner with, the running speed that you're running, the unit stability, so the die station, the whole press, the stability of everything that the web is running through, cylinder deflection, making sure that you're not asking for a size of a roll that is beyond the maximum diameter that you should be running so that you don't have problems die cutting. The materials, of course, cause a lot of problems with die cutting, not just the liner, but the face stocks and the adhesives. The pressure that is being applied to these, making sure that you monitor and keep the pressure where it needs to be accurately. And one of my pet peeves is friction and temperature, making sure everything's lubricated and kept clean. Next slide. So Maxcess has hydrojacks. We have the best hydrojacks in the market. They're easy to use. It is a tool that you should be using, that it allows you to see that you do have the right pressure front and back on your die, and that you can monitor that pressure. It also is a great tool for understanding if there's a problem in the die stack up. If you see this needle jumping around a lot, something's going on. It shouldn't be doing that. It may have small movements to it, but not a lot of movement. So it's a great tool for just preventive maintenance to see what's going on. We can recalibrate them, send them back out. In fact, we recommend that every couple of years to have them recalibrated. So it's a great tool to have, and I highly recommend using them. Next slide. So with that, with the hydrojacks, your cutting depth is very important. The accuracy on that cut depth is very important. When you're not cutting adequately, you could be cutting too deep, and then you can have delamination if it's a paper liner, or if it's a polyester liner, it may want to snap on you whenever the labels are being applied. So keeping great pressure on there, the adequate pressure, and allowing the die to do the job that it is made to do, the cut to the right depth is very important. So a perfect cut should just cut to the silicone. it shouldn't be cutting deeper or lighter. And as we see with the light sample here, if you're cutting too light, your paper face stock is going to get fuzzy. Or even if it's a film layer face stock, it's going to go up with the matrix. So getting the right depth of cut is very important as you're die cutting. Next slide, please. So some of the precision required in uncertain times. So the liners are changing. They're, I would say they're better than they were 2 or 3 years ago. They've gotten better again. I think the shortage of liners was a big issue with the quality of the liner, but they are improving, but they are also getting thinner, and so the accuracy of this die needs to be that much tighter. And then also as you go to the film liners, the polyester liners, from a 1-2 or the 9/10 polyester liners, everything in that stack up needs to be that much more accurate. And the dies that we were using for cutting a paper liner are not the same dies that you would use to cut to a polyester liner. The clearances have changed. We do sell probably more adjustable anvils today because of this switch from paper to film to be able to use the same die as long as the blade angle was correct to begin with. Next slide, please. So typical liners, 9/10, we're seeing more 7/10 liners, and also all the way down to less than half a tenth thick. So cutting to release liner requires a 1/10 accuracy. That's very fine. A tight tolerance die is required to be able to cut to that level of accuracy. Here we show a reference of a human hair is 2,000ths to 3,000ths thick. So we are talking very small numbers on the accuracy that these dies need to be able to hold to. Next slide, please. Thermal expansion. Thermal expansion happens because of pressure and speed. You need to hold that die down. You need to hold it down well, and as you're running, things are going to warm up a little bit. It notes here a 20 degrees rise in temperature, which doesn't take long. You know, if you're running 300 foot per minute and you have 1,000 pound aside on your die, it won't take but maybe 20 minutes to warm up to that degree. And at that level of temperature change, you could lose as much as 1/10 of an inch in clearance as those bearers warm up. That pulls that blade away a little more. On a solid anvil, the only thing you can do is just add more pressure, which creates more heat. So keeping things lubricated, clean and lubricated, is very important. On our mag cylinders, when you're running thin films, we recommend our XT mag cylinder. It has D2 bearers, and the D2 takes longer for it to even warm up, but it also doesn't compress as much as other steels would. So you get whatever that die is made, the clearance that's in that die, it's going to give you the same clearance that when you put it on your mag cylinder, you're not really able to collapse and get more depth of cut with it. And it's very important. We want that die to get the right clearance. We don't want you to have to pressure it to get to that. Next slide, please. So the die station and beyond. The older machines, they have, it's inherited into them. They don't hold as tight of registration as they used to. And so there's a lot of this equipment out there still being used. We can put load cells in a press, a standalone, so that you can actually monitor that tension that you're getting. And that's very important because if you see changes during the run, I would expect registration issues, possibly die cutting issues because of that. And as you run faster, the web guide needs to be able to adjust to these quicker speeds. So the actuators need to be able to respond faster. We also, they're talking about printing errors and the use of cameras. As you're running faster, it's even harder to see everything in register. So it's very important to have a camera so you can watch your print-to-print registration and your print-to-die cut registration. Lubrication, I can't say enough about it, but I will say just keeping the felt wipers clean and oiled well is very important to the longevity of your dies. Next slide, please. This is really talking about stripping your matrix away. One of the tricks is the smaller the label, the smaller that idler should be that you're stripping off of. If you're running large labels, a bigger idler, or a boot-shaped label, a larger idler, so you have a better transition of that matrix being removed off of the web. We have products that actually have the rings that you can use to help dispense the label out, so that it's not going up with the matrix. It's very important. Just like the way the web is going around this anvil in this picture here, you don't want to go straight through with your web. That allows the web to flutter, not lay flat to that anvil, and it can cause poor die cut quality. So getting a wrap around that anvil is very important to a good die cut. Next slide, and I think this goes to Daryl. Daryl?
Thank you, Greg. So now we're going to talk about tension control and how the tension in your web can impact your die cuts, or really any process that you have going on in your web that you're trying to achieve. Tension control, unfortunately, is one of the most overlooked aspects of any web application, and that's because if it works, you don't see it. You don't know it's there. You're not looking at a die cut. You're not looking at a guide moving something. You're not looking at a coding or some process where you're actually doing the converting portion, whatever you're doing to the web. But if everything's good, it's invisible, which is a good thing. But for that reason, it's often overlooked. And as Greg mentioned, we're seeing thinner and thinner materials being used, and that's where tension control becomes more critical. In the old days, if you're running 60-pound weight paper or board stock or something of that nature, you've got a wide range of tension that you can run where everything's going to be fine. Somewhere between breaking the web from too much tension or it going slack and bunching up or falling on the floor if you don't have enough tension. So you've got a very wide range in there. So a machine that may have been designed to run a heavier material, now all of a sudden you're trying to run extensible films, lightweight materials, very thin films, materials that stretch very easily. All of a sudden you're running into problems that didn't used to be there. And it's typically because the machine wasn't designed to run those. And it's this invisible tension in the web that's causing the problem. So as it relates to die cutting with tension control, basically it typically ends up, there can be other things, we're going to talk about unwinds and rewinds, but it really in a die station, where it can show up is in registration issues or deformation issues due to a stretching of the web. So when we talk about registration of a web for die cutting, or whether it's die cutting or printing, there's basically two types. There's phase or timing. So that's how the dies interact with each other and how they strike each other, or how you print, how it overlays on the other material. So that's phase or timing, and that's not something we can control with tension. What we see with tension issues in registration are basically stretch. And what we're talking about are materials that are viscoelastic materials. We're not talking about stretching something to a yield point or beyond a yield point. Where you run into trouble are materials that will actually stretch and then over time will relax back to their original length or shape. So what happens, obviously, in a die cutting situation, we've tried to represent that here with this image. If we pre-stretch a material, and it goes through the die stretched, and you die cut whatever shapes that you're die cutting, and then over time that relaxes back, you're going to end up with deformed or not the die cut that you were looking for in the material. And that's what we can control. Now, where do you control that? If you've got multiple die stations, you've got phase issues between that, you can't control that. That's set by the dies themselves. But where this typically starts is at the unwind of the material. And it can be pre-stretched at that point and stay stretched throughout the process until later it's trying to be used, or after it gets to the die and all of a sudden you've got these weird shapes that are showing up here on these stars at the top that were due to the material being die cut when it was stretched, and then it relaxes back to its natural form. So that's what we're going to talk about. And most of this, as I said, it all starts at the unwind of the material. So that's where that initial stretch can actually take place. So let's go to the next slide, Eva. So we're going to talk about, there are three different categories or ways to do tension control to make this better, or to eliminate those issues. And this would go for unwinds or rewinds or even point-to-point processes in the middle. So the tension in the web is a direct function. It's directly related to the torque applied to a roll through a brake or through a clutch or through a drive. But the torque applied to the roll and that radius, the radius of that roll, or the diameter of the roll. So the formula for it is tension equals the torque divided that you apply divided by the radius of the roll. So the first thing, that's going to be the basis for what we're going to talk about here. So let's start with the most basic type system, a manual system. What's a manual system? Well, a manual system is still adjustable. You can increase or decrease the tension, increase or decrease that torque, but it's done manually. So this is an operator who's using his calibrated fingers, and he's tapping on the web. Oh, I need more tension, I'm going to turn the knob up, or I need less tension, I'm going to turn the knob down. Well, in the case of an unwind or a rewind, that diameter is changing. So you need a babysitter there to constantly make that change as it goes through. So in our first analogy here, our first example, this would be like if you were driving a car and you get to a big hill, okay? And if you had a fixed accelerator, which is what the manual system is, if nobody touches anything, what's going to happen? The car is going to slow down as it goes up the hill. So what's going to happen with us? If the torque remains constant, the radius changes, the tension's going to change. Okay, so that's the first example. Second example, let's say we have an operator who's really good at this. He sits there and he taps on the web all day, and he makes his change to a potentiometer, to a knob on the machine, to increase or decrease the torque to try to maintain a tension. That can work, but it's really only as good as the operator doing it. And it's never going to be as consistent as you want. And it's never going to be, that's a very manual type system. That's why it's called manual. It's a very manual system, and you're going to get inconsistencies. And you're going to have to pay somebody to stand there and turn a knob. So those are manual systems, very common. Why are they common? This is the most basic, the lowest cost type system there is. But if you're seeing inconsistencies, this could be where it's coming from. So if we go to the next system, Eva, so now we're going to get into the automatic type systems. So open loop is our first category for that. So in an open loop system, you still have an operator who can set a set point for what he wants the tension to be. But what we're going to do is we're going to measure something that's going to be calculated as to how that tension is going to change, or how that torque is going to change as that radius changes. Now it's open loop because in this case, what we typically do, there are different ways of doing it, but we would do like an ultrasonic system to measure the diameter of the roll. So as the diameter of the roll changes, the output of the control to a brake, in the case of an unwind, would change proportional to that diameter. So this is not a PID loop system. This is just a proportional system where we're changing torque proportional to roll diameter. So this would be like driving a car equipped with a sensor that detects a change in incline. It adjusts just to keep the speed constant, but is not measuring the speed of the vehicle. So what you run into with that, you could be driving let's say you're driving your truck, you get to this hill, your truck has a sensor on it that detects the incline, so it knows to make an adjustment to try to keep the speed constant. But what that sensor doesn't know, because it's only looking at the incline, it doesn't know, if you're hauling a load of bricks in the back of your truck, if the truck's empty, it doesn't know how much load you have on it. All that knows is the incline has changed. And that's all these systems know, is that diameter has changed, and I'm going to change the torque proportional to that diameter. Now, the next category of systems would be a closed loop system. So closed loop systems can come in different forms. What most people think about is the example that we're showing up there in the corner, our load cell systems, where you're actually using a load cell to measure the tension in the web. You're providing feedback to the control, and that's controlling the brake, which is controlling the torque. So you're getting direct tension control based off of the actual load that the load cells are seeing, or the tension that you've got in your web. So in this analogy, this is like driving a car equipped with cruise control. It adjusts the acceleration based on the speedometer reading. So this would be the highest end, or the most consistent, best way of controlling that tension being infed into your system. Now, there are multiple ways of doing this. There are different subcategories under closed loop. Most people think of load cell, and that is the most common type of closed loop tension control system. Dancer arms are also very common in our industry. And what dancer systems do, they're a little bit different, and I could teach a whole day-long seminar just on dancers. I'm a big advocate for it if you need it. But dancer systems are position controls. So what a dancer system does is the loading on the arm is what sets the tension, and the purpose of the brake and the dancer in that case are to keep that arm from hitting the top stop or the bottom stop to maintain the tension, the desired tension that you're looking for. So a little bit different. Those are used when you need accumulation due to out of round rolls or indexings or things like that. So two very different systems. They both achieve the same purpose, but can both be very accurate and both give you very good tension control throughout your process. So if we go to the next slide, Eva. So what I just talked about kind of goes for the unwind or the rewind. Now I want to talk about other things that can impact your process when you're die cutting, when you're printing, when you're doing anything. But specifically to this, what I talked about before with those three categories of systems, that's unwinds, rewinds, anywhere through the system. What I want to talk about now are your rewinds. On the rewind end of the machine, basically when you're building a roll and you're rewinding the material, you're trying to make a good package. Your goal is to make a good package for the next unwind, so you have the best advantage to start off with that process to run smoothly. So we're trying to make a good roll and a good package. Now, there's something very specific about rewinds that's very important to talk about. These are some common issues or common things that people see on rewinds. Telescoping would be the first one, where you're actually getting the material squeezing out of the end. And it's I'm sure you've all seen that, and you can see it in the example here. A lot of times we'll get calls on this and say, hey, I've got a guiding issue. I've got a guiding issue because I've got this telescoping roll. Typically, that's not a guiding issue. Typically, that's a tension issue. And what's happening there is we've got all of these inwound forces squeezing on that core. And if it's a slick material, if it's a film, if it's a coated paper, something with a very slick surface, then that can slide on itself. If you squeeze too hard on that core, you can literally squeeze the core out of the middle of the roll. And we're going to talk about that in the next slide, what that looks like and what causes that. Crushed cores are another type of issue that you might be seeing, where maybe you can't get the roll of the material off after you've wound it, or maybe the core is damaged after you take it off and it's hard to use and you can't put it on the next machine because the core is collapsed. And the next one would be starring. We've kind of tried to show that with this example on the end of the roll. You can see this star pattern, and sometimes it's actually just lines that striate clear out from the axis of the roll to the outside. That's typically the result of either a core that's crushed a little bit and the material is relaxed, or if you're running a thicker material, maybe you've crushed those inner layers of material, and all of a sudden that roll has tried to relax on itself, and it causes this starring or this pattern that shows up on the end of the roll. So what is this, and how do we make this go away? How do we do this? So Eva, if you go to the next slide. We do this by using something called taper tension, and most rewinds can benefit from using some amount of taper. If you imagine, if you see our image on the right, with every roll of, or every layer that we put on that roll of material, if we've tensioned it, we've stretched it slightly, and every roll we put on there is squeezing harder and harder on that core. So if you imagine taking a rubber band and you take it around your finger one time, it doesn't do a whole lot, right? But if you keep holding out a little bit of tension and keep wrapping that rubber band, the end of your finger turns the same color as this roll over here on the right. So that is telling you that that is squeezing harder and harder. And if you think about what that's doing to your finger, think about how much you're squeezing. If you've got a roll of film or paper that's 3 feet in diameter, every layer on there is squeezing more and more. How many layers do you have on there? And every one is putting inward force on that core until that core cannot take it anymore, or until you get the telescoping. And the telescoping would be like if I took a wet bar of soap and squeezed it, am I just going to crush it? No, it's probably going to shoot up out of the end of my hand. And that's what telescoping is. You're squeezing so hard, you haven't collapsed the core, but you're literally squeezing the core out of the middle of the material. So taper tension is a good thing. And what taper tension is actually the reduction of the tension set point as the roll builds. So I might start off my roll. I've got to have a good foundation. It's got to be a good firm foundation. Let's say I'm starting off at 20 pounds of tension in my web. And as that roll builds, I'm actually going to back off my set point to where when I get to full roll, maybe I'm only at 8 pounds of tension or 10 pounds of tension. But my output's still going up, but it's not going up in a linear fashion proportional to the roll diameter. And I'm setting that value through our open loop and closed loop controls. We can actually set that value to where you can put the amount of taper that you want into the system to make those things go away. But those are the three big indicators that tell you need taper tension. If you're having any issues on your rewinds that look anything like telescoping, crushed cores, or starring, sometimes you might see it as dishing on the face of the material. That could be an indication of it as well. Or if you're I've even seen it with materials with adhesive on it where they're squeezing the adhesive out of the end of the roll and the middle part of it's dry because all the adhesive's been squeezed out. Those are all indications that you need that very important thing called taper tension. Okay. So that would be on the rewind end of the machine. So let's go to the next slide, Eva. So we're going to bring Greg back in here, and I'm going to let him start. There's a few things on the top, so we just want to give you just a few things to look at as we wrap this up, to look for and things that you can do to make your process better. So I'll let you start with yours, and then I'll wrap it up here at the bottom.
Okay, thank you, Daryl. As I mentioned earlier, the use of changing the diameter of your stripping idler is very important. You need to be able to adapt to the label length. If you're doing a small label, you can't just use a 3-inch diameter idler, or else that matrix is not going to dispense that label out. It's going to want to go up with it. So going to a smaller idler or a bullnose bar, straight bar with a rounded edge to help push that label out, dispense that label out. It's very important. The same goes as you go to a larger label repeat. You don't want a small idler in place. You want a larger idler in place. And then I think it also goes right back to you, Daryl.
Okay. Well, there are a couple of things that I wanted to mention to look out for when applying whoever's tension control to your process. The first one is on load cells. If you're putting load cells in a machine, load cells are pretty easy to adapt into an existing machine. You just find an existing idler and you can put load cells on the end of that and make that your sensing roll. But it's very important when you're doing load cells is you have to isolate the load cell from the roll. Meaning, if if I have the roll of material and the next idler after it is my load cell, as that roll diameter changes, it's going to change the plane that that load cell sees, and it's going to change the direction of force that that load cell is seen on. And it's not going to be an accurate load cell reading. So basically, what you want to do is you want to make sure you have at least one roll between the unwind or rewind and where you put a load cell, because you want to keep the wrap angle fixed. You don't want the wrap angle to ever change on a load cell. The next thing, which is probably a can of worms and a whole nother presentation, but it is very important, I think, to address. A lot of people do speed control, which you can do for tension control. Basically, it's called draw instead of tension. But basically, I turn this roll faster than this roll, and that puts draw on the material, and that tensions the web. You can do that, but the preferred method is to do it through a torque device, whether that's a clutch or a brake or even a torque drive. That's the preferred method. And the reason for that, I mentioned earlier that tension is a function of the torque divided by the radius of the roll. Those are absolutely proportional. So they're directly related. Changing the torque based off the radius is going to give you a tension. Speed and tension are not. So any small variations you have in a speed control, so even if your roll's not completely round and has a lump in it, that's going to create a speed variation. Small changes in speed will result in large changes in tension because speed and tension are not directly related. So torque control is always going to be the preferred method from any reputable tension control supplier. They're going to tell you that. The torque control is always going to be the preferred method for tension control. Okay, so I think that's our tips and tricks, and I think we're ready for any questions that anybody might have.
Hold on,
Ethan.
we got a few. Yep, got it here.
Okay.
Thanks again, guys, and thanks everybody listening. Let's go through some of the questions and or discussion topics that have popped up here. Does stripping the matrix off the magnetic sheet cause the die to wear out faster?
If you're taking a abrasive material, especially against the die as you're stripping it away, yeah, it will prematurely wear it out. But it's also not the best idea anyway, because you also take a chance of scooting that flex die. That matrix being removed away can actually move the die. We've actually had people lose a die into the matrix because they're stripping off it. Just pull it right off of the cylinder. But to the question, it really depends on the abrasiveness of that material. If it's not really abrasive, it really shouldn't be doing anything to this. It's just that we don't normally recommend stripping off of a flex die.
Great, thanks, Greg, for that answer. What is your recommendation for an RD score unit, before or after the die cut?
Well, it all has to happen before you remove the matrix. So it can be either or. I think the best place is the easiest place to access it. That is the one thing about the RD score, is you need to be able to make adjustments to it. You need to be able to move them in and out, change the blades. So an easy access area is really what you want. But whether it's before or after die cut, it really shouldn't affect the RD score itself.
Got it. Thanks, Greg. Kicking this one back to you, Daryl. I had a funny feeling this was going to come up again. Can you go back and please discuss the difference between phase and stretch one more time?
Okay. So stretch is absolutely what it sounds like. Basically, what we say when we talk about stretch is that's a deformation of the web. So you're stretching your web prior to being die cut, okay, or prior to being printed on, or whatever you're doing to it, okay. So any resulting registration issue, whether you're printing or you're die cutting, that would result from the material actually stretching would be controllable through tension control. We can affect that. Phase, basically, if you look, and I know we're doing die cutting, but if we talk about the print, like a print cylinder, the print cylinders and being different diameters throughout, because between print heads, there's typically no tension control. The tension control is set by those print cylinders and the diameter of those. So if those are the wrong diameters and you've got the wrong phasing, or if you've got a servo controlled registration where you can actually adjust where a die cut is, where a die cylinder is, or where a print cylinder is, that is phase, and that's phase and timing to where you can actually adjust those things. That's really a function of the mechanics of the machine, okay, and how the press or the die cutter works. That's what we can't change. We look at registration issues for tension control based off of the web itself, and is that web being stretched or relaxed too much at the wrong point? So when I talk about phase or I talk about timing, that's in the machine itself. When I talk about stretch, that's physically what you're doing to the web. Does that make sense?
I think so.
But
We'll wait for a response.
either one of those can result in the same kind of possibly looking issues.
Got it.
But you got to
We
determine
find-
which one it is.
Check. We find our operators compensate for the degradation of ejection foam's impact on part size by adjusting tension controls. Is there a more straightforward way of monitoring or addressing this issue? Who wants that one?
Could you repeat that again? I thought you were going
Yep.
somewhere else, and I was okay. And then I'm not sure I understood the question.
We find our operators compensate for the degradation of ejection foam's impact on part size by adjusting tension controls. Is there a more straightforward way of monitoring or addressing this issue?
Greg?
Yeah, I was thinking that it's talking about the part, are you cutting foam? I guess the question I
Yeah.
have is this the foam that's being cut and the length of the foam? Because I could see change in tension to change that, and that definitely would if it's especially if it's extensible.
It goes back to the stretch thing that I just talked about. If you're stretching the foam, then yes, adjusting the tension would stretch it less or stretch it more to get it to the part size that you're looking for.
Got it. Will the rotor repel die repel tactile dust?
Repel it? No, it's not going to repel it, but well, let's put it this way. The coefficient of friction, it is very slick when we put a rotor repel on. Things do not want to stick to it. So dust, and especially with a die spinning, most likely there is no reason for it to want to stick to that die. It's too slick with this coating on there. So I would like to say that it would, and if anything, at least it will make it easier to remove if it does get on there.
Yes.
Thanks, Greg. How do we best control tension when printing rotary screen that is just on one side or edge that tends to build the roll higher where the rotary screen is?
Well, there's not a lot you can do to tension across the web. You tension through the web. And it's kind of an average of through the web. Now, if it's building up and you're talking about on a rewind and you've got more of a buildup on one side than the other side, that's where we were probably looking at doing some sort of and you're trying to build a good roll, but because of the thickness difference in the material, it's not winding good. That's where like oscillating winders and oscillation systems would come in to where you can oscillate that rewind to make sure that those thicker layers are not on top of each other, so they build up more and it evens out the roll and makes a better roll. I'm not sure. If that's the answer I have based off of what I understand you're asking. And again, if on any of these questions, if we're not getting your question answered specifically, if we're not understanding it, feel free to reach out to us afterwards. We're more than happy. It's what we do, to talk about your specific applications and what we might do to solve whatever problems you're having. But that's
Yeah.
what I'm hearing there. So
Yeah, well, we're trying to do the best to answer the questions as Daryl just said. We'll give the emails to Daryl and Greg at the end of this if we didn't answer it clearly, or if you want to have a more in-depth conversation.
Right.
Does Maxcess manufacture an auto oiler for the AccuStrike adjustable anvils, and can that be installed on an existing anvil?
We don't do oilers for oiling the bearers. Actually, what we do make is a truck that goes on, on top of your die that has an oil reservoir. I do know there's aftermarket oilers out there though, that are either time-based or revolution-based. They can also be battery operated or actually plugged into to voltage to activate them, but we do not have an oiler that automatically applies the oil. The only thing, like I said, is on our trucks, we can have reservoirs on our truck, so that it is always giving a small amount of oil onto the bearers.
Great, thanks. I'm bouncing around here between chat and questions. Our magnetic sheets continue to move on the cylinder and even on a full rare earth magnetic cylinder, and we even tape the sheet to the cylinder. What would be the main cause for this movement? And a lot of the sheets have a lot of blade contact at all times.
And that is really that's exactly what I would have said. You must have a lot of contact into the web with your die, a lot of very busy die. Wrapping the anvil with your web so that the web has the die has a very small footprint into that material, so that allows only what's contacting at the time when it's cutting, and instead of going flat through there. That helps a lot. Larger mag cylinders, of course, the bigger the area, the more magnets you're going to get. Making sure, pre-curling the die so that they are already curled and not laying flat when you take them off. That is another way of helping it out. But the rare earth, the high strength magnets, very important if you have a very busy die, because that web is actually moving. You'd think everything was moving at the same speed. They're not exactly the same speed, but that's what it's called, throw on a press. It's slightly off, but it will influence that die. The more contact you have into that web, especially if it's a thicker web, there's that much more blade into it. So pre-curling larger mag cylinders, making sure you wrap the anvil and high strength magnets, those are the solutions to that.
Great, thanks, Greg. Here's some clarifications. Let's go back to the original question. This is on the degradation of ejection foam's impact on part size by adjusting tension controls. So what our attendee was saying, thanks for the response. They were referring to the cutting of more rigid materials, paper/films, for example, and how they behave inside cutting cavities packed with ejection foam. Ejection foam that degrades through the constant running conditions.
Okay. Yeah, so it's and as I would refer to it as the die foam. So they've packed the die with this foam to help. It's used many reasons. To hold the material down while you're cutting, because like I said, wrapping that anvil is very important. A material that can squirm underneath the die cut is not going to cut as well. So holding it down with the foam while it's cutting is very important. But also using the right height of foam is very important. If your cavity, say on a flex die, is 10 thousandths tall, your blade height is 10 thousandths tall, and you're using a foam that is much higher than that, it's going to wear that foam out. The scrubbing action is as those rolls are turning, it's going to wear that foam out. So getting a either a more compressible, like an open cell foam, opposed to like the pour-on closed cell foams, might be the solution here, because it will collapse better and not stand proud above the blades. And it works the same for solid dies too, with the taller blades that a solid die will have, making sure that that foam is not standing too proud above that blade is very important. You know, there's a lot of different foams out there. There's a lot of suppliers for these foams, so critiquing that probably is maybe the best choice here, is finding the right foam for that product, so that you don't have the problem with wearing the foam out, or even scooting it on the die.
Which could be, because the question was about they affect it right now by changing the tension. It could be if the foam is too tall, too much foam in there, by increasing the tension, you're yanking down harder on the material and causing and forcing it down to that lower level. So it sounds like it does all go back to the amount of foam, or the height of the foam, or the compressibility of the foam, if tension makes a difference. So.
Great. Do you have a recommended oil to use on wipers?
Yes, not synthetic. Synthetic's very thin oil, so it's more likely to fling. I prefer a straight weight oil. You don't need the 1050, because it's not going to get cold. You don't have to worry about, you know, like with oils, the startup on a cold day or anything like that. It's all about heat. I like straight 40 or 50 weight oil. Saturate the oil wiper before putting them in, because if you add oil to a dry wiper, it just pulls to the inside. So if you fill them first and then just take a little excess off, now when you add oil to that wiper, it stays on the outside.
Great, thanks, Greg. There's been a question can we go back to the PowerPoint slide that highlights the ideal depth of cut one more time? Just wanted you to go over that. Eva, can you go back to that, which is the too deep right cut, too shallow cut? And the question also was, will we receive a copy of the PowerPoint? When we release the recording, we will also send along a PDF of the presentation, so you guys can have some of the details. Greg, back to you.
Okay, and most people do auto applied labels. This label is going to go to an applicator that whether it's high speed or just to the applicator, so that you can apply the label to the product. If you're cutting too deep into that liner, what'll happen on the cross blades, especially the lineals, really don't matter as much, but the cross blade, if you cut too deep into it, for one, you can force adhesive down into that liner, and now the label is going to want to follow it. It also it bends different when it's being applied. That label wants to follow through with the liner, not dispense out if you're cutting too deep. So you just want to cut to the silicone. Ink stains, very important, doing an ink stain. I know that the film liners, we can't do ink stains on them. It doesn't do any good. Actually, with the film liner, a lot of people do the snap test. There's strain tests to see if you're cutting too deep. But back to a paper liner, you use an ink. We use markers. There's ink stain kits. So we sell ink stain kits. You may see some few spotty areas as you flip it over and look at the backside, but that really tells you, are you cutting through that silicone if that ink penetrates through the liner. And again, to the too light, if it's a paper face stock, you'll see the fuzzy edges around the perimeter of this. And that means we're not cutting adequately to that silicone liner. If it's a film, usually if it's a film face stock, that label is going to want to go up. It's not going to cut all the way through. and most likely we'll just go up with the matrix.
Got it. Thanks, Greg, for recovering that. Advantages and disadvantages of adjustable anvils versus a standard anvil for 2 mil film face 92 film liner. Sorry, 2 mil film face 92 gauge film liner.
You know, we prefer a solid anvil when it comes to the thin films like it. A 1.2 adjustable anvil is great. You have more of a window for imperfections, you could say, with a 1.2. But when you get into that 92 gauge, you have very little room for movement. And a solid anvil, there is no movement. We would rather have a great die on a great mag cylinder with a very good anvil, cutting it and watch the thermal growth, making sure everything is lubricated, because you don't have much room for thermal growth when you're running 92 gauge. That 1/10 of an inch clearance change by thermal growth makes a big difference. And on a solid anvil, all you have is pressure, which creates heat. I would like to say that the adjustable anvil is the best solution, but honestly, the best solution is a solid anvil with a good mag cylinder XT with the D2 bearers and the high end precision flex die that we offer.
Great, thanks. Daryl, let's kick this into you. What's the best way to know if you have the right amount of tension? We often see that if we move the tension on our machines, we often see if we move the tension on our machine, the material doesn't collect evenly.
So every process is different. We are tension control experts, but we don't typically tell people what tension to run on their process. Typically, the customer tells us they want to get to this, and we size everything and get them the right products to get to a specific tension. Now, I'm not sure I understand again what exactly they're saying. It collects differently. I'm not sure what that means exactly. To whether that would tell me they would need more or less tension to solve that problem. So it's very difficult. Again, we don't tell people what tension to run. We can help you get to what you want to run, or we can help you based off of what you're seeing, tell you, okay, maybe you need more or less, but I'm not really sure I understand that question.
Got it. Okay, we'll see if they come back with a clarification.
And again, they can come back or reach out to me directly,
Yep.
and I'll be more than happy
Yeah,
to talk about the application with them.
And again, we will share the emails of Daryl and Greg here at the end. Let me see what our next question is. Regarding different roller sizes for stripping, what would you consider a smaller label versus a larger label?
A smaller label, I'm talking about like a 1-inch circle or a 1-inch or even less, because as you get into like the standard presses have like 3-inch idlers on there. That 1-inch label, if you're not pushing it out, whether it's with an idler with bands on it. I remember when I ran a press, I put tape on the idler to help dispense it out. But about 1 inches or less, I would consider a smaller idler diameter, and all the way down to not even just an idler, but a bar going across that you could strip off of to help dispense that label out.
Got it. Thanks, Greg. How common is it to actively control the temperature of the anvil?
The first part of that, I missed that, Keith.
How common is it to actively control the temperature of the anvil?
Not many people do. There are a select few, and it's definitely when they're running thinner films because of that small window that you have with thermal growth, creating problems with the die cut. Now, if you put like a vortex tubes on there, this is taking compressed air and separating the hot and the cold out, and now you're just blowing cold on there. That's a great way to keep the bearers cool. so that you're thermally not growing. It doesn't take a lot of air to do this, but it also comes down to how fast are you going to run? How much pressure do you need will determine how much cold air that you're going to need. But we normally don't see many people trying to cool their anvil. Typically, to me, it's just keeping the lubrication on there well and making sure the bears on all the surfaces are in good condition, not worn, not pitted, because that causes friction. But again, there is tools out there, like I said, the vortex tubes to blow onto the bears to keep them cool. That is the best solution available.
Great, thanks, Rick. We'll run a little over here because we have a couple more questions. Eva, if you can put up the emails for people that need to drop off that so they can reach out to Greg or Dale directly. This is a good one because I know as you guys have been out in the field, we're seeing that shift from a lot of people with a lot of press side knowledge and experience and operators to more of a not lesser skilled force, but different skilled force. Let's call it that way. But this is a good one. What are some of your favorite go-to quotes or formulas for new operators in the die cutting process? Any advice is appreciated. Like when you mentioned tension equals torque divided by roll diameter. Any golden rules you guys can throw out there for the audience today? Quick sound bites that'll register.
Our rule on crossblade is for pressure is for every inch of crossblade, you have 120 pounds total pressure. So, and we don't want to go below 400 pounds a total pressure because it'll just, the die will lift. But the rule of thumb is 120 PSI of pressure, total pressure per inch of crossblade. To note on that also, whenever you order a die and you get in the packing slip, it will tell you on there how much pressure we applied to that die to get it to cut. And that's a good starting place. One thing I ask though is when you start there, sometimes you may want to back off a little bit because you don't need excess pressure. Excess pressure causes heat. So see where it works for you, but that is a good starting pressure.
And I would say keep it simple. It's I wish I could say that we were brilliant and that this is rocket science. None of it is, especially tension control. And the more simple and basic you can keep it, the better success that you're going to have. There are a lot of people that have a lot of ideas about how tension control works and how to tension a web properly, and they throw everything but the kitchen sink at it, and they end up creating more issues than they're solving. So keeping it simple, keeping it basic, it's basic knowledge is going to do you well, and then the less stuff you can throw at it, the better it's going to work.
Got it. Thanks, guys. Here's a couple more that came in. Does an adjustable anvil work with metal to metal or two-level tools?
Well, the two level, you're not going to get, you can't tweak both levels if it's a two-level tool. You can only, you tweak them both together with the adjustable anvil. The metal to metal is a touchy one. A removable blade sheeter die, I would never put on top of an adjustable anvil. The tolerances in those of the blades and everything, it could pound on that anvil and prematurely wear it out. If it's a die, an engraved die, cutting metal to metal, yes, you can do it. Just be careful because you can also adjust it to where you flatten out your blades. But it is okay as long as it's an engraved die.
Got it. Thanks, Greg. Second part to another question. We are kiss cutting sandpaper to liner with a D2 die, and the sandpaper is shaving the blades. Is there a solution for that?
Well, to combat wear, you want to call it, on cutting sandpaper, one of the most successful ways of doing it is to run it upside down. Actually cut from underneath. If you're cutting it out, if you're cutting to a liner, you're going to have to cut from the top. But if you're blanking it out, cutting from the back to the face is the best way to keep the die to last longer. put an RD90, our steel types, a softer steel type, wear out that anvil, not the die, is a solution for the metal to metal. But the chrome, if you're cutting pressure sensitive, the most amount of chrome you can get on this die will help you give you the most life in it. So what we call here is our yellow jacket die. It works great for thermal transfer, for glass bead material. You do the same for sandpaper. You need the most amount of chrome you can get on this die.
Got it. One more here, and then I think we'll put it up. What are some of the best ways to control discrete die cut products after they are cut out of the web?
Can you clarify that question for me, please?
I'll see if the person is still on and can do that. As we're wrapping up here, we got a couple other suggested topics. I'm just going to throw that out to the group. A couple people interested in hearing about sample calculations and how much material strain to operate through die cutting, specifically how strain is handled after the label portion is cut, since the cross-section area is now effectively reduced after the cut. So food for thought there, gentlemen, or somebody may be reaching out with you, with that question, but that's a topic people want to hear a little bit more about. I think that's pretty much it. So I want to wrap up and thank Greg and Daryl, our technical press side experts, for their insights and expertise on our first technical conference. As I said, their emails are there. If you have any questions, please feel free to reach out. We appreciate everybody taking their time to spend with us today. We hope it's been beneficial. Again, our first technical seminar was on slitting. This one was on tooling and tension. Send us any topics in the chat or the Q&A you want to see us cover in the future. We're planning on doing these again as we get to the year. Our hope is to get 5 to 6 of these over the course of the year, but we want to make sure we are answering the questions that you all have. And again, our press side experts are here to help you out with any challenges you may have, and we're happy to go forward with this. As I said, we do have a recording of this webinar. We'll publish that to all the registrants, not just to you that attend. And per the request that came up earlier, we will attach a PDF of the slides so you can reference those as well. Thanks, guys. We appreciate it. Thanks for taking the time. We're here to help you with your end-to-end press needs. Anytime you guys have it, feel free to reach out to us, and we're here to help. Thanks, everybody. Have a great day.
Thank you.